Hello dear students, welcome, and I am Dr. Punima AS, and in this video I am going to tell you the concept of binomial distribution. Let me share the screen now. Yeah, here it is. Share computer sound. Okay, share. Here it is. So, there are certain phenomena in nature which can be identified as Bernoulli's processes. Okay, Bernoulli's processes, binomial distribution is also known as Bernoulli's process. Okay, so when do we call it a Bernoulli process? When do you call a natural phenomena as a Bernoulli process? There is a fixed number of n trials carried out. Each trial has only two possible outcomes, a success or failure, true or false, etc. Probability of occurrence of any outcome remains same over successive trials. Trials are statistically independent. Binomial distribution is a discrete probability distribution which expresses the probability of one set of alternatives P and success P and failure Q, and is given by the formula P of x is equal to x, n c x, p to the power of x and q to the power of n minus x. So what does this say? See, for example, in a binomial distribution, you can only find the formula will give you only the exact number of successes. For example, if you want to find in 100 trials, how many times you get head, say you want to get what is, if somebody asks you what is the probability that when I throw the coin 100 times, I will get exactly 7 heads. Then you have to put x is equal to 7, n is the number of trials, that is 100, c 7. What is the probability of success? Getting ahead in each trial is 0.5. So remember this, when P is defined as the probability of success, it means that probability of success in each trial. For example, if I throw a coin once, what is the probability of me getting head? 0.5. What is the probability of me getting tail? It is also 0.5. So if I define getting a head as a success, P is equal to 0.5. Q is the success. Q is the probability of failure. That is probably in this case it is the probability of getting a tail, and it is defined as Q is equal to 1 minus P. That is 1 minus 0.5. So here, if I will just use the pen here. So it is Q is equal to 1 minus 0.5. N is the number of trials. In this case, I told you we are taking 100 trials and we are interested to find out how many times we get heads. So we get probability is 0.5 of success is 0.5, and we want to find out exactly 7 successes because 7 we want to know this probability of getting 7 heads exactly. Then we get it as 100 C7. Okay, so P of x is equal to 7. Assumptions for binomial distribution. For each trial, there are only 2 possible outcomes on each trial. S is success and F is failure. The number of trials, N, is finite. For each trial, the 2 outcomes are mutually exclusive. Okay, P of success, that is probability of success, P is constant. P of failure is given by Q, which is equivalent to 1 minus P. The trials are independent of the outcome of, and the outcome of the trial is not affected by the outcome of any other trial. Probability of success P is constant from trial to trial. Notation, P denotes the probability of success. We already know that. Okay, anyway, to be very clear, P denotes the probability of success. N is the number of trials. Q denotes the probability of failure for N trials. P of X is equal to denotes the probability of getting exactly X heads, X successes among N trials, X successes among N trials. X denotes the specific number of successes. In our example, we wanted to find out in 100 trials, what is the probability of getting exactly 7 heads. So X is equal to 7. If you want to find out the probability of exactly 20 heads, X will take up the value of 20. Okay. So S and F are success and failure. I think it is a repetition. Probability of success is P. The probability of failure is equal to 1 minus P. Q is the probability of failure. N denotes the number of fixed trials. Okay. It can be applied to single variable discrete data where results are number of successful outcomes. Where number of successful outcomes. Okay, number of successful outcomes in a given scenario. For example, number of students with green eyes in a class of 40, number of plants with diseased leaves in the number when the number is 50. Used to calculate the probability of occurrences, that is P of X is equal to X, NCX, P to the power of X and Q to the power of N minus X. Find the probability that the number of red lights will be exactly 5 when there are about 20 flights, or we will take probability that the number of green-eyed students will be less than 7. Exactly 5 when the number of lights is 10 means we will find out X is equal to 5, that is equal to 20 C5 when there are, if there are 20 traffic signals which you have to pass, what is the probability that the number of red lights you will encounter is exactly 5? 5 is equal to 20 C5 into probability of occurrence is, again 0.5. There is a possibility of getting red light is 0.5. That is equal to 0.5 to the power of 5. And what is the probability of failure? Q is equal to 1 minus 0.5. That is equivalent to 0.5 to the power of N minus, there is no space, so I am writing it here, 0.5 to the power of 20 minus, this will be 20 minus 5. Okay, so this is how we calculate. But you, in a discrete probability distribution, refer my earlier video on basics of probability distributions in my channel. Okay, for discrete probability distribution, we can only find the exact number less than 7. Now this question is saying, asking you, when the in a class of 40, what is the probability that the number of green-eyed students will be less than 7? Okay, so here less than 7 means you have no choice but to find out P of 0, P of 1, P of 2, P of 3, P of 4, P of 5 and P of 6, right? So you cannot find this less than 7 in a single formula. In every time, if you have to put P of X as 0, find the probability. I mean, you have 6 steps before you can arrive at this kind of answer. Probability that the number of deceased plants will be more than 10. More than 10 means there are 50 plants. Okay, in the previous problem we have said it, we have 50 plants. So more than 10 means it is 11, P of 11, P of 12, P of 13, P of 14, up till 50. That is 40 probabilities you have to calculate, add up, and you will get the answer. But then it is more easy to find out this probability of 0 less than 10, P of 0, P of 1, P of 2 till P of 9, and subtract it by 1, because this is the basic axiom of probability. Sum of total probabilities is always equal to 1. That Kolmogov's axiom will give us the respite from lengthy calculations. Of course, as you must already be aware, we have powerful technological platforms where you can calculate all these probabilities within a minute. But then let us learn the basics first. Okay, so when you are calculating by hand, this probability that the number of deceased plants will be more than 10, you have to calculate P of 11 to P of 50, the choice is yours, or find probability of less than 10 and subtract it by 1 using the basic axiom of probability. That is also possible. Okay, so binomial probability formula is given by P of x is equal to x, ncx, P to the power of x into Q to the power of n minus x. For x is equal to 0 to n number of trials, again we have repeating it. So measures of central tendency, mean mu is equal to n star p. Standard deviation is n star p star q in multiply n star p star q, that is number of trials into probability of success into probability of failure, and find the square root. Variance is this standard deviation square. Just simply remove the square root sign and you will get this answer, n star p star q, where n is number of fixed trials, probability of success is one of the trials, and probability of failure in one of the n trials. So this is about the measures of central tendency. Okay, so with this, I end this video after explaining the basic concepts of binomial distribution. Remember, binomial distribution is one of the discrete probability distribution principles. Okay, the discrete distributions are those in which discrete variables are involved. Discrete variables are those variables which vary in whole numbers. These are also called discrete metrics. Okay, so this is about binomial distribution. I hope you have understood the concepts. If not, repeat. If not, watch the video again. Happy learning. Stay home and stay safe. I sign off here.